Did you know that New York City faces some of the most complex construction challenges in the world? From limited space to unique soil and rock conditions, the Big Apple constantly pushes engineers to think outside the box to come up with sustainable practices. Join us in this insightful episode as we delve into the world of New York City construction challenges and sustainable practices with our special guest for today, in the person of Eddie Chiarelli, Vice President at New York Concrete Corp and Strata Industries Corp. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. But before we get started, let's hear a quick word from our sponsor for today's episode, that being PPI, a Kaplan company.
PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
Eddie, thanks for coming on the show. How are you doing?
I'm doing great. Thanks for having me, Jared. It's been it was good catching up with you again at down in Dallas when we were at BFI.
That was cool, man. You never know who you're gonna bump into in the airport, right? That's great. All right, cool. So let's do this. Let's kind of start things out by you telling us a little bit more about yourself. You could talk about your career journey, and of course, how did you get to the current role where you are now as Vice President at both New York Concrete Corp and Strata Industries Corporation? How did all that happen?
Well, it's been a long journey. All right,
take your time.
All right,
take your time. You got a captive audience here. Take your time.
No problem. Well, honestly, it started off when I was in college. That was back in 1999. That's when I first started college. And I went to college to be a mechanical engineer, because I loved Ferrari. I loved auto racing, Formula One. I had family who was into it, and I wanted to design race car engines. So you're probably saying, what does this have to do with geotechnical engineering? Well, when I went to, now it's NYU Poly, or NYU Hannon School of Engineering, I had a mechanical engineering program for such. But halfway through my first semester there, they were going to cancel the program. So I quickly had to pivot. It's either move out to Detroit, find another school, but I had scholarships. And my second favorite thing to do was to build from an early age. I went to work with my father, 12, just sweeping, in the construction industry. So I was always around that. I always had the fascination of how things were built and put together. So from that, I transferred into civil engineering. Civil engineering, I started as an summer intern for Thornton Tomasetti. I wanted to be a structural engineer. So off the bat, I had a great opportunity working with a lot of the guys who are still there. And I learned a lot in just a few months. But what I learned was that I didn't just want to be a, quote, design engineer. I wanted to learn more. So I looked more into getting experience working with the construction end of things. So following summer, I went to go work for Bovis. Back then it was Bovis. Today it's a Lend-Lease, and I think in New York, they just closed down. Now it's Conciliate. But anyway, it was a CM firm. And with that, I had 2 summers there, and I learned a tremendous amount from the engineering end. So I still liked engineering, but I had my focus switched to engineering with a construction management background. And from that point, I started working full-time at Bovis. I was there for about over 10 years, and I went through the ranks as APM, PM, senior PM, etc., but working on a lot of large projects here in New York City. Very large projects. And really cut my teeth in my first full-time project there on gut renovations, structural engineering, where I had to run around the building to figure out how the existing building was built and how to retrofit the new work. And me as a young project manager, I had to tell an engineer, well, the design doesn't work. And, it was difficult for me back then. I thought engineers had everything figured out. But anyway, I digress. From that point, I was working a lot on the structural end, and from that involved foundations. And in foundations, I liked what I was doing. And one day, the owner of New York Concrete asked, well, would you want to come work here? No, I'm not interested in that. And asked again and again. And then I'm like, you know what? Why not? So I started working with New York Concrete about over 12 years ago, and originally started as a chief estimator and a senior project manager, and helping put together bids, estimating. Part of estimating is also figuring out how to perform the work, to plan out the work so you can accurately price it. And once we were successful at work, which one of my first successful bids was Hudson Yards, of all projects.
Wow.
And as soon as I, won that bid, I then had to be the senior project manager running it. So at the time, we had no other real senior guys. So I was learning a lot of things on the fly. So it was a lot of, what's the terminology, trial by fire or baptism by fire, and did a lot of that, but gained experience. And smaller project led to bigger projects, more complex projects, different services. And in about 10 years, we amassed a lot of equipment and crews on the drilling end. And then we had to keep that busy in the time when our business was union-based. A lot of the work was going to non-union contractors, and we had to figure out how to keep things afloat. So we started a sister company called Strata, which I too became the VP of, overseeing all the engineering and the drilling end of things, where we were just a specialty drilling and driving contractor so that we could work with other large CMs and GCs on much bigger projects. Like New York Concrete can't take on like $1 billion bridge project on its own, but we can be a subcontractor and perform, a $20 million package on a $1 billion project. And that was the goal of Strata, is to be more of a very specified specialty subcontract. And that's how I became, VP of companies, and here overseeing all the engineering and drilling and project management and estimating, everything but own the company.
Okay, excellent. That's awesome. And I remember, I remember you back at your Bovis days, right? I'm thinking probably the job in downtown Brooklyn is probably where we met, right?
Yes.
So it's been cool to see your career progression. So thank you for sharing that. So we talk about, the scale of things that you're working on. The Gateway Tunnel project, I've heard in some circles, right, it's been compared to monumental feats like the Hoover Dam and the Golden Gate Bridge, right, depending on who you talk to. And as a key member of the New York Concrete team that's responsible for phase 3, the portion of this mega project, can you talk a little bit about this phase and why is it challenging and why is it exciting to you?
It's very challenging, but at the surface, it seems like a very simple project. It's a typical, well, not typical, it's a cut and cover tunnel that it's only about 700 feet long. At its maximum depth, it's about 80 feet deep and 70 feet wide. So essentially, it's a sloping trench that is 50 feet down to 80 feet in depth, 700 feet in length altogether. And once you reach subgrade, it's to just pour the concrete tunnel encasement back. So in concept, it's easy. The challenge comes in is that you're doing it in New York City. You're doing it with numerous stakeholders and agencies that all have jurisdiction. DOT, DEP, DEC, Parks Department, Long Island Railroad, Amtrak. The list goes on and on and on, right? There's the property owner or property lessee. So you have all these entities that all have jurisdiction, and you have to make them all happy. And you have to maintain traffic, maintain the right-of-way, maintain an active railroad rail yard, which is next to us, which is within the influence line. And also, what's bisecting the whole cut is this thing called the High Line, which is an elevated railroad track that's repurposed as a public park. And it is active. Active means there's people on it every day who get to go on a nice leisurely stroll and look over and get to see the active project. And we have to suspend this thing 80 feet in the air, right? Over the cut. And it's all design built. So I was tasked to figure out how to get it done on time and on the schedule. So that's a daunting task unto itself, right? And I mean, it's a mega project, but it's a small part of a much bigger mega project. And some of the challenges, I mean, it's exciting. I mean, that being part of what's going to transform New York City for generations to come, to me as an engineer, as someone in construction, someone who lives in New York, that's, you can't ask. This is why we wake up every morning and go to work. So it's going to make an impact, which is important to me. But this project, some of the other challenges that we have from a technical point of view is that we're excavating in, from a geotechnical condition, some very soft clays, which makes the design of the SOE challenging. Below that, we have to excavate through a very thick layer of very, very hard rock. So there's over 50,000 cubic yards of rock to remove in a small window of time. Vibration limitations. Again, at the High Line overhead, just holding up that High Line and how to span beams that run over 100 feet to suspend this load is quite daunting. So those are some of the challenging items that we had. And the amount of rebar, just the execution of the concrete work. Again, simple tunnel box, two-track tunnel box, but the amount of reinforcing in there is unlike your traditional tunnel because there's an overbuild going on top of this tunnel later on. So there's going to be a 70-story tower that's bearing on top of this tunnel, which makes the reinforcing scheme, quite intense, to say the least.
So you're wondering, where does the actual concrete go, right?
Yeah, exactly. There's no room for concrete.
Wow, that sounds cool. I like the way you say it, that in concept it's not complicated, but when you put all that together in the same recipe, it does become pretty complicated.
Yeah.
So a question I have for you is, how do you plan to expedite the schedule, and what type of innovative geotechnical solutions is your team considering to achieve the goal you have in front of you?
Well, it was quite a few. So part of this design build that was interesting to us is we had to think outside the box. Part of the team here, I understood that if we just simply follow the indicative plans, we may have not been successful. So one of the main things was suspending this High Line. This High Line, it was designed to be suspended using plate girders that span 2 secant walls. So over 100 feet, you have 2 massive plate girders at each High Line bed. The High Line, again, is the raised railroad track. And we said, no, can't be done. Can't be done in steel. And we were questioned. We were grilled during the pursuit. Why do you say it can't be done in steel? And we said, the approval time, the lead time, fabrication, logistics, it's not going to work with the schedule you're looking for. So one Saturday, many nights and Saturdays pursuing this, I said to myself, we're a concrete company. Why not concrete? So we designed a concrete solution in lieu of steel, where we were fortunate. To this day, it's the only solution that works with the schedule, the way it transpired with the approvals. Again, many stakeholders. So what everyone thought from the design team would be a quick, 3-month approval process has turned into over a year process. So right there, we would have been in a very, very bad position if we had steel. So converting it to concrete was a big time saver and cost saver as well. So concrete, we're able to, instead of prefabricating these beams and having them laying around like steel and then getting cranes to swing them in, we're able to modify the design a week or two before we're actually building it. And all we need is formwork. We put up the forms, we get stock rebar, we're building beams. And there they are. Other things with that whole underpinning scheme or suspending the high line, we designed more cantilevered beams instead of full-length beams that span wall to wall. That meant having to drill tie-down caissons to support the cantilevers. What was interesting is the indicative design called for low headroom diaphragm walls, really low headroom walls that required specialty equipment. And time and cost saver was to eliminate the D-wall. So in one area, we eliminate the D-wall by going with micropile soldier piles and jet grout leg. Using low headroom drill rigs, we can install 14-inch diameter micropile casing down to bedrock, through bedrock, and then jet grout, basically lagging, watertight lagging, in lieu of a diaphragm. Another area, there was a soft eye area where the next phase of the tunnels would tie into. Again, the indicative design indicated a D-wall there. So studying it said, well, why didn't we need a D-wall at all? Right behind the D-wall was a huge jet grout mix that's part of the scope. So in working with Muser Rutledge, we developed a way where we were repurposing this jet grout mix to act as our SOE wall. We had to augment it by adding some additional jet grout mass to it. But essentially, we took a very complex curved portion of the tunnel end, and we made it into a typical 2D analysis instead of a 3D analysis. And we just used a big hunk of jet grout to act as our SOE. So that saved a lot of time and money. Then there's some, easier items like the secant pile wall. I opted to go with a larger diameter so that we can reduce number of piles. Reducing the number of piles, albeit more concrete, more spoils, it's less schedule, right? Quicker. It definitely saves on the schedule. What else? For our bracing system, we have these large struts that are mandatory. So in lieu of going with fabricated pipe struts, we're likely going to switch to prefabricated bracing system struts. So, which I've successfully used in a lot of other projects for large SOEs. So typically you see them from more like steel sheeting, smaller trench applications, but essentially our tunnels are large trench. So we're just using larger struts. So those are some of the main things. There's a lot of little things that would save time and money, but the concrete beams and eliminating those D-walls were things.
Excellent. Well, thank you for sharing that. And again, congrats on the win. Sounds like an awesome project. Wish you lots of success. And as somebody that's regularly using that mode of transportation, I thank you in advance. So let's see, given your background in structural engineering and also in construction management, what are some of the unique challenges that you face when you're working on large scale construction projects in New York City?
New York City.
And really this applies to any densely populated metropolitan area,
what comes to mind, and this is from my contractor hat being on, is agency approvals. That's key. So understanding the lead times, the key lead times, knowing in designing something or preparing just the plan, what would have the best chance of gaining agency approval, right? And having the right consultants on your team. You know, one of the things that I did when I first joined here is we were using good, reliable consultants that were smaller in nature, but unfortunately they didn't have a lot of they weren't as familiar with all the players at different agencies. So they didn't have the same level of relationships. And, you know, working with the right consultants who know all these agency players on a day-to-day basis makes a big difference. And it makes a project go a lot smoother and get started quicker. So agency approvals is one. Other issues in cities is working with neighbors, getting access agreements in place beforehand, and working with them face-to-face to develop trust. Sometimes that's not possible, but working with, their proxies or whoever they put in charge is important because you're working next to them for a long period of time. And it's important to instill, confidence. Traffic traffic is extremely important. I mean,
for sure.
With foundations, two things, soil and concrete. More so concrete is a challenge. When we have large pours, planning ahead is necessary, knowing the traffic patterns. How much concrete can you actually get there? Will a 100-yard pour take you an hour? It's going to take you 3 hours, 4 hours, right? That's very critical. Where are you? Are you working next to the United Nations? Or are you working like at Hudson Yards right off 12th Avenue, the West Side Highway, which traffic is pretty light in most parts of days, and you have a better flow. So that is a key thing. So I'd say those are the top 3 items, working in the urban environment.
Excellent. Thank you for that. Good stuff here. Good stuff here. Let's switch gears a little bit. Sustainability. It's definitely something that's a growing concern in the construction industry. How do you integrate sustainable practices into your projects?
We don't have too many things that we can do, but we do imply sustainable practice. Easy thing, low-hanging fruit is recycling concrete and steel. With our work when we're performing excavations, there's existing concrete we're disposing of, that gets recycled. Extra concrete on site gets recycled, and all the scrap steel gets recycled. All soil that we truck out, very few projects go out to a landfill. So most of the soil has beneficial reuse of some sort, which is good. Low emissions equipment and using newer equipment technology, I think, are the other ones. So we always try to invest in new equipment whenever we can that utilizes the latest technology. And with that, it reduces power consumption. And now we're seeing a lot of equipment moving over to electric-based. So that has an ability. Like simple things like concrete buggies, you can get electric-based ones. But what's newer on the market, which we haven't delved into yet, are large equipment, like large drill rigs. They're now even making electric-powered drill rigs, which is fascinating.
I don't know.
Yeah.
Wow.
So investing in that type of equipment, it keeps us sustainable. And there's other things is locally sourcing materials. So most of our materials are from within the tri-state area. We don't have to travel too far to get it. And we're trying to stick with it.
Excellent. So let's see. How important would you say teamwork is? And you hinted at this already. And also communication among the various stakeholders, especially as it relates to geotechnical engineers when you're working on large construction projects. What are your thoughts there?
Oh, it's extremely important because good teamwork, if you instill good teamwork, it leads to faster schedules, fewer avoidable errors, less grief, higher morale, repeat work, reduce costs, like I said, faster schedule, but it leads to a positive experience. Whereas the inverse is the same, right? Poor teamwork, poor communication leads to errors, which leads to delays, higher costs, low project morale. It results in claims and a lower likelihood of working for that client again. Yeah. It doesn't make anyone look good. It causes strain. So it's extremely important. So getting clarifications, so communication, anything from clear RFIs to scope to what's really happening, around the site. It's very important. Secrets don't usually help.
Yeah, that doesn't go over well. Excellent. All right, cool. Before we take our break, final piece of advice you want to share with folks who are listening or watching so they can be successful and have a positive impact on their careers, Eddie? What are your thoughts?
Go work in the field. That I stress. It would teach you valuable lessons, valuable constructability lessons. Because at the end of the day, as a geotech engineer, you're building a project, whether it's on the structural side, the strictly geotechnical side, you're doing something. How's it done? You can write a spec, you can put together a drawing, but how's it done? Unless you go in the field, you won't understand that. Also, for geotechnical engineers, some advice is understand the business side of things. We're in the business end of it. So we're not doing this for practice. Sometimes there's some pro bono. So what's the end result? How is this going to help out your client? How's it going to help out your organization? How's it going to help advance the industry, right? Sometimes you have to think broader, at least in my opinion. How is this going to help the industry? As an engineer, going back to the field, understand the constructability is key. Be practical. That makes you a better engineer at the end of the day. You can relate to clients better. You can relate to contractors better and other stakeholders. And, for engineers, thinking outside the box. Just because someone hasn't done it does not mean it can't be done. That's a common theme in my career and something that I've been put up. So I stress that to young engineers. Don't be scared because no one else has done it. You have to do your homework, take the proper steps and due diligence, but don't be afraid to be a pioneer.
There you go. It's a good note to pause on. Well, thank you so much. We're going to take a break here, and we're going to come back in just a minute. Close this one out with Eddie and our Career Factor Safety In segment. Stick around. All right, welcome back. It's time for our Career Factor Safety In segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Eddie Chiarelli from New York Concrete Corp and Strata Industries Corporation. So, Eddie, you've already had a very successful career. And of course, I'm not pushing you into retirement. You still have more of your career. But when you look back at your career so far, what's something that you've implemented that's given you a career factor of safety?
Interesting question. If I was asked this early on in my career, I wouldn't know how to answer. But thinking about it now, I'd say learning how to pivot, learning how to self-perform and learn new techniques and services so that you could add value to your organization, to your clients, learning how to take on new projects that you previously were not comfortable with, so you could provide additional services in the future. So that, in a way, leads you to broaden your horizons. Just because you design a widget doesn't mean you're stuck designing that widget. You can pivot to something else. And I've learned to self-teach myself those things by, constantly speaking with other professionals and questioning everything so that I can understand new information. And a key part to that too, I'd say, Jared, is to, learn it for yourself. Don't just have blind faith in it. Just because an expert tells you things at times doesn't mean that it's always the right information. So I'd say what I do for myself is I try to understand it, reverse engineer it, visualize it, and see if I can reach the same conclusion. And if I can't, question it. Say, well, it looks like it should be like this instead of like that. Can you explain why or what happens in this condition or that case? And I found along my career that a lot of the time those so-called experts, they may be wrong at times, or there's another way of doing it that they have frankly not thought about. Because, coming into things with a fresh set of eyes and not having the experience that others have, you may discover that there's a new, better way of doing things. And, that's led to, let's say, my career path to basically come up with different ways of doing things that those so-called experts agree is a better, more efficient way of doing things. Anything from simple plan to engineering machine parts, right? So, with drill rigs and machine parts, I've done my fair share. And start going back to the original answer is learn how to pivot, think outside, the path, and what else can you do, and try to teach yourself.
That's excellent. Thank you so much. And what I really like about that is that, for the person that's listening in or watching, that's, 5 years in the career, 10 years in the career, everybody can have an input towards getting us closer to a solution. And sometimes that fresh set of eyes is just what a team needs. So thank you for that, Eddie. And thank you for coming on and sharing all the great insights with us. You shared a lot of great information and advice. It's going to be helpful for our listeners and those that are watching. How can people find you? If somebody wanted to reach out, are you on social media or you have an email you want to share? We can put it in the show notes.
I have a simple email, which is Eddie, EDDIE, at NewYorkConcrete.com. All spelled out, one word. Simplest way to get in touch with me. And you can check me out on LinkedIn. There's not many Eddie Chiarellis out there. So you'll eventually find you that way.
Excellent. All right, good. Well, thank you for coming on. This is a lot of fun, man. Appreciate it.
Thank you.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. Please feel free to go to geotechnicalengineeringpodcast.com where you'll find a summary of the key points discussed in today's episode, as well as any links to any resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.